Hello everyone, hope all of you are doing well. Today we are going to discuss plus 2 physics practical. We can start with Ohm's law. The aim of the experiment is to determine the resistance per centimeter of a given wire by plotting a graph of potential difference versus current. Here we have to verify Ohm's law by plotting a graph between V and I. Also we have to determine the resistance per centimeter of a given wire. The apparatus required is a metallic conductor, a battery, one-way key, a voltmeter and an ammeter of appropriate range, connecting wires and a piece of sandpaper, a scale. Now we can go through the theory part. According to Ohm's law, at a constant temperature, the current flowing through a conductor is directly proportional to the potential difference between its ends. That is, I is proportional to V, or V by I is equal to R. That is, the formula used to find the resistance of a given wire is equal to V by I, where V is the potential difference between the ends of the given resistance coil and I is the current flowing through it. In order to find the resistance per centimeter of the wire, first of all we have to find the resistance by using the experiment. Okay, then we will calculate the resistance, and the length of the wire we can measure by using a scale. Then we can find resistance per centimeter by dividing the resistance with the length of the wire. Before starting the experiment, we have to note the range and least count of voltmeter and ammeter. Suppose here we are taking the range of the voltmeter as 3 volt. That means we can measure the voltmeter from 0 to 3 volt, and the range of ammeter we are taking as 500 milliampere. That is, from 0 to 500 milliamperes we can measure by using the ammeter. Now the least count of voltmeter and ammeter we have to note. What is least count? Least count is the minimum value or the least value that can be measured by using an instrument, right? So in this case, in voltmeter we are taking it as 0.05 volt. Also, suppose we are having an ammeter of least count 10 milliamperes. Now we have to check the zero error in both the cases, in ammeter and voltmeter, so that if there is any error in the apparatus, that will affect our reading. So before starting the experiment, we have to make sure that there is no error, or if there is any error, that correction we have to apply. Okay, otherwise it will affect the readings. Here I am giving a set of readings only to get an idea about the magnitude of the values. Okay, don't copy the readings because that will be different from your exact readings. Now we can start the experiment. For that, first of all we have to connect the components according to the circuit diagram. The circuit diagram is as shown in the figure. We can see that from the positive we have to connect to the ammeter positive, and from ammeter negative we should connect to voltmeter positive, and across the voltmeter we have to connect the resistance wire, because the resistance wire should be always parallel to the voltmeter. So both the ends of voltmeter and the wire should be connected together, and from the negative end we have to connect to the top of rheostat, and from the lower portion of the rheostat we have to connect to one end of the key, and from the other side of the key we have to connect to the negative. And there is no polarity for key, that means anywhere we can connect that. Okay, and all the connections should be tight. Now we have to close the key, and the rheostat is adjusted to read a current I. The corresponding voltmeter reading also we have to note and write down in our tabular column. That means the ammeter reading and the voltmeter reading. Okay, the experiment we have to repeat for different values of current by adjusting the rheostat. Okay, and then we have to calculate V by I, that is R. Then we will find the mean value of R. Now we can just go through the tabular column. Here we can see ammeter reading, voltmeter reading, and resistance. R is equal to V by I. So it is not compulsory to make the ammeter column into two, because here we can see observed and the corrected values. So for our convenience we are making like that. It is not compulsory to do like that. Only 3 columns will be enough. We have already noted that the least count of ammeter is equal to 10 milliampere. That means each division in ammeter means 10 milliamperes, and the least count of voltmeter is 0.05 volt. That means each division of voltmeter will be equal to 0.05 volt. Whenever we are taking the ammeter reading, suppose we are getting 50th division in our ammeter, then that is not the value, that is the observed reading only. So to get the actual value, we have to multiply that 50 with least count. That is 50 into 10 milliamperes. That will be 500 milliampere. That is the ammeter reading. And for getting the corresponding voltmeter reading, we have to check the voltmeter division. Suppose we are getting the 16th division, then that value we are writing as the observed reading, and for getting the corrected value, here also we have to multiply that 16 with least count. Here least count is 0.05 volt, that is 16 into 0.05 volt, that will be equal to 0.8 volt. Now we can calculate the resistance by using the equation R is equal to V by I. That will be equal to 0.8 divided by 500 milliamperes. Okay. Then we can consider one more example. Suppose we are getting the 35th reading in the ammeter as the ammeter reading. So what will be the actual value? Then we have to multiply with least count, right? 35 into 10 milliamperes, that will be 350 milliamperes. And the corresponding reading in the voltmeter will, suppose the 11th division is coming here. So what will be the actual value? So that 11 into 0.05, that will be equal to 0.55. Then R will be equal to 0.55 divided by 350 milliamperes. Like that we will continue the experiment for minimum 5 readings, and then we have to find the mean of resistance. Okay, so that will be the unknown resistance. Whenever we calculate the R value, we will get a constant. We can draw the graph by taking potential difference along x-axis and current along y-axis. Then we will get a straight line graph that is passing through the origin. Now we can consider a slope here. Then what value we will get? Slope is equal to y by x, right? So I by v we will get. So for getting R, we have to find v by I, so that we can take the reciprocal of that slope. Then we will get the value of resistance. We have to mention the scale also. Here we have taken along x-axis 1 centimeter is equal to 0.1 volt, and along y-axis 1 centimeter is equal to 0.1 milliamperes of current. Also the length of the resistance wire we can measure by using a scale, and it is found 28 centimeters here. Now we can write the result. That is, it is found that the ratio V by I is constant, hence current voltage relationship is established. That is, V is proportional to I, or Ohm's law is verified. Then unknown resistance per centimeter of given wire, that we have to mention here with units. We can write down 2 precautions and 2 sources of error also. That is, precautions: voltmeter and ammeter should be of proper range, and the connection should be neat, clean and tight. The sources of error: rheostat may have high resistance, or the instrument screws may be loose. Now we can conclude our video. If you like my video, please like, share and subscribe. Thanks for watching.